Hey everyone, today I am discussing about the sampling distribution of the sample mean. Let's get started. Now we are going to see an example. This example based on 1000 samples we considered in here for intelligent questions or IQs. We also imposed a normal curve over the histogram. We simulated in here 1000 samples of IQs each. We need to determine the sample mean of the 1000 samples and we obtain a histogram of 1000 sample. We also imposed a normal distribution over the histogram with mean 100 and standard deviation 8. Let's make the interpret of the figure. This figure suggests that x bar is normally distributed, that is that the possible sample mean IQs for samples of 4 people have a normal distribution. Now let's talk about key fact 1. Key fact 1. This key fact 1 indicates that if our variable is x of population and it is also normally distributed and it has a mean mu and it has also standard deviation sigma, then we can say that for sample size of n, the variable x bar is also normally distributed and it has also mean is like as the mean of x, but now the standard deviation is sigma over square root over n and it has a little bit changed than the previous. Now we are going to see an example. In here we see that our mean is 100 and standard deviation is 16. So if we pick the sample size n equals 4, then we can calculate the standard deviation like the previous formula. This formula, according to the formula, we can calculate 16 over square root over 4, that is 8. So we can say that our sampling distribution of the sample mean is a normal distribution with mean 100 and standard deviation is 8. Now let's pick the sample size 16. Then we can calculate easily 16 over square root over 16, that is 4. So we can easily comment our sampling distribution is normal distribution with mean 100 and standard deviation is 4. In next slide we are going to see the figure. The figure 1 indicates that the normal distribution for IQs are normally distributed. The second figure shows that the possible sample mean IQs for samples of 4 people have a normal distribution with mean 100 and standard deviation is 8. Okay. Then the third figure shows that the possible sample mean IQs for samples of 16 people have a normal distribution with mean 100 and standard deviation is 4. Now we are going to see the key fact. This key fact is related the central limit theorem. If we have relatively large sample size, the variable x bar is approximately normally distributed no matter whatever the distribution of the variable which are under consideration. And we also can say the approximation becomes better and better with increasing sample size. Now we are going to see the figure, and this from this figure we can check the plausibility of central limit theorem. So from this figure we can notice that this is not normal distribution, it is rightly skewed. So however, according to central limit theorem, the sampling distribution for sample mean can be approximately by a normal distribution when sample size is large. So to make the fact plausible, for sample size of 30, we can see the next slide. So yeah, this is a figure, it's a cool figure, and we can say that for sample size 30 and it's a normal distribution. Now we are going to see the key fact 3, and if we have population variable is x and mu is our mean, standard deviation is sigma, sample size is n, then we are going to say the first point is our population mean equals our mean of x bar. The second one indicates that our population standard deviation equals standard deviation of x bar. Third one suggests us if x is normally distributed, then we can say that x bar is also normally distributed no matter whatever our sample size. Third one is no matter what about our distribution, and if the sample size is large, we can say that x bar is approximately normally distribution. Now the next slide we are going to see the sum figure, and first figure, in figure A there are 4 figures. In figure B, there are also 4 figures. In figure C, there are also 4 figures. And figure A is for normal distribution, figure B is reverse J-shaped distribution, and figure C is uniform variables. So, and we can see that from figure A, our all curve are normal curve, distribution is normal distribution no matter the sizes. But in figure B and C, and we can see that whenever our sampling distribution n equals true, so the curve, the distribution is far from being normal distribution. But whenever sample size n equals 10, so it is already normally distributed, and whenever the sample size n equals 30, then we can say that our distribution is very close to normal distribution. Thank you everyone.